Hello, my name is Cecil, and today I'm going to be walking you through a Physics 212 problem revolving around harmonic motion. This one's going to be spring-based. And so the question is, when a 3.4 kilogram bucket is released from being held at rest position of a vertical spring, the spring stretches 6 centimeters once it comes to rest. A, what is the spring constant? The same spring is then placed on a frictionless horizontal surface, and the bucket is exchanged for a 64-gram plastic bottle. If the bottle is moved from the spring's rest position, B, what is the period of the resulting oscillation? For the first part, from Hooke's law, we know that F is equal to Kx, where K is the spring constant, X is the displacement of the spring, and F is the force on the spring. In this example, we know that the force that's on the spring is going to be however much this bucket weighs. So if the spring is stretched and there's this bucket, the weight of the bucket is what is pulling the spring down. And the weight of the bucket we know is 3.4 kilograms. So we know that the force of the bucket on the spring is going to be the force of gravity of the bucket. So it's going to be mg, which will be equal to kx. G, we know, is the acceleration due to gravity, which is 9.8 meters over second squared, and m is equal to 3.4 kilograms. If we just plug those in, and we plug in the fact that we know the displacement, or the amount that the spring moves from rest, is 6 centimeters, or 6 times 10 to the negative 2 meters, then the force will be equal to 3.4 kilograms multiplied by 9.8 meters over second squared, which is equal to 6 times 10 to the negative 2 meters times k. So we'll divide off the 6 times 10 to the negative 2 meters to get k on its own. K is equal to 3.4 kilograms times 9.8 meters over second squared over 6 times 10 to the negative 2 meters. Cancel those, and if you multiply it out with the calculator, K is equal to 555.3 newtons over meters. And that's for part A. Now for part B, we have, instead of a bucket be holding down the spring, we're looking at something a bit different. The spring is now horizontal, and instead of a bucket, we have a bottle attached to it. We just move it away from rest position, so we either compress the spring some amount, or we pull the bottle away from rest position in the other direction. The point is that some displacement occurs, and what we're looking for is the period of oscillation, or the time per oscillation, more or less. We know from our equations that T is equal to 2 pi m over k, where m is the mass of the object, k is the spring constant. Then if we plug those in, we'll have that T is equal to 2 pi times the square root. In this case, we now have the 64-gram bottle. 64 grams is the same as 6.4 times 10 to negative 2 kilograms. So I'll write that in its place. Or that's equal to if you calculate it out, we will get that t is equal to 0.0675 seconds for each rotation. So basically, it takes 0.0675 seconds for the bottle to go from the extended position or any position, and then to get to the compressed state, and then to return to its original state. That's how long it takes, is the period. So I hope this was helpful, and I will see you in the next one. Have a great day.